Alright, so firstly we want to find AG. So if we have a look at AG, we just want G, take away A, and if you look at G here, it's gone, whoops, there we go, G. We've gone across the X, so this way is the X, it's gone in that direction 0, but it has gone 1 to the right, which is the Y, and it's also gone 1 up, which is the Z. So that's G. Take away, that's the position vector for G, and A, if we look at A, it's only gone on the X-axis 1 in, but the Y and Z axis, it's 0. So putting that in, it did ask for component form. So 0 minus 1 is minus 1, 1 minus 0 is 1, and 1 minus 0 is 1. So that's AG in component form, so therefore it should be nice and easy for us to find the distance of AG. So we're just going to square root. They're all 1s, negative 1 squared, which is 1, 1 squared is 1, 1 squared is 1, so we can see we'll get root 3 for that distance. Alright, so then we are looking for OH and the distance of OH. Well, let's just look for OH first, and then we can also look for that distance. So OH, where is OH? Is the centre of the square BCGF. BCGF is this front one here. So let's think about this OH, the centre of that, I should say. So what we could do is start at 0, and you could go all different ways, but let's go from O to C. Let's come across here. So I'm going to go from O to C, and then I'm going to come halfway across here. So halfway across now, halfway across C to B, which is really the same as halfway across O to A. So C to B, which is O to A. And then I want to go up, halfway up there, which is the same as going from O to D, halfway up O to D. So same vectors there. Okay. So O to C is, I need to just rub that out so we can see better. Alright, so if I go from O to C, I'm just going on the y-axis 1, so the other ones are 0. And then O to A, we already know that one. And then O to D, D is just up the z-axis. So what we've got here is just a half from that one. We've got a nice full J from that one, and from K we've got a half as well. So now if I'm looking for that length, the magnitude only, then I'm going to go square root of a half squared, so it's a quarter, square root of 1 squared, and square root of a half, square of. Alright, and you can see that quarter plus quarter is a half, so 1 1/2 or 3 on 2, I'm just going to write it over here, so that's root 3 on 2. I could make it rational by doing that, so I'd get root 6 on 2 for that magnitude of vector OH.